Today, we are going to trace the history of the computer. It's an incredible story that stretches back thousands of years and leads, believe it or not, right to the device you're using to watch this. So, let's dive in. Okay, I know what you're thinking. That sounds like a trick question, right? On one hand, you have this tiny supercomputer that can talk to anyone on the planet, and on the other, a simple wooden frame with beads. But there is a common thread that ties them together across all those centuries, and it's humanity's relentless desire to calculate and, well, to compute. The leap from one to the other is it's staggering when you really stop to think about it. We went from a tool that couldn't even store a single number to devices in our pockets that can hold entire libraries. This whole explainer is really about how we bridged that unbelievable gap. To really get how we got here, we have to rewind the clock. I mean, way back, long before electricity, to a time when the whole concept of computing was just starting to form. Not in silicone chips, but in people's minds and with really simple tools. You know, the groundwork for all of this was laid down piece by piece over centuries. It starts with things like the abacus, one of the very first tools for doing math. Then you have the brilliant logical rules set down by ancient Greek mathematicians like Euclid, which are basically the great-grandparents of what we call algorithms today. Fast forward to the 19th century, and you get these incredible visionaries, like Charles Babbage, who designed a mechanical computer called the analytical engine. And right there with him was Ada Lovelace, who wrote the first ever computer program for it, a full 100 years before a machine that could actually run it even existed. Amazing. And just look at this timeline. Look at how long these ideas took to cook. We're talking about thousands of years between the first simple calculator and the first real design for a programmable computer. The slow, steady progress, well, it's about to hit the accelerator. Big time. Okay, this is the moment. This is the pivot point in our story. It's when we ditch the mechanical gears and levers and plug into the power of electricity. And with that, we unleashed a speed of innovation that the world had just never seen before. But before we could actually build a modern computer, we first had to figure out what a computer even is. And that's where the genius Alan Turing comes in. His Turing machine wasn't a real physical thing. It was a thought experiment, a brilliant theoretical model that laid out what any computer, in theory, should be able to do. You can think of it as the universal blueprint for every digital computer that followed. And here is the first machine to actually be built from that kind of thinking, ENIAC. This thing was a monster. It filled an entire room, weighed 30 tons, and was powered by nearly 18,000 glowing, hot vacuum tubes. It was an absolute marvel for its time, but those vacuum tubes, they were a huge problem. They were big, they burned out all the time, and they used a ridiculous amount of electricity. And then came the invention that changed absolutely everything, the transistor. It could do everything a vacuum tube could, but it was tiny, incredibly reliable, and used way less power. This wasn't just a small improvement. This was a fundamental shift. It completely changed the game, making it possible to build smaller, cheaper, and way more powerful computers for the very first time. So with the transistor, we finally had a way to shrink computers down from the size of a building to the size of a desk. But it was going to take a few more big ideas to get a computer into every home. And here's how it happened. First, the microprocessor. The Intel 4004 literally put the entire brain of a computer onto one tiny little chip. That single invention led straight to the personal computer revolution of the 70s and 80s. But even then, these early PCs were complicated. The last piece of the puzzle was the graphical user interface, or GUI. All of a sudden, with icons you could click and a mouse to move around, you didn't have to be a computer scientist to use a computer. Anyone could do it. Okay, so now we have millions of personal computers sitting on desks all around the world. What's the next logical, world-changing step? Well, of course, you connect them all together. What started out as a US military project called ARPANET grew up to become the internet. But the real transformation came in the 1990s with the creation of the World Wide Web. That's what turned the internet into this global library, a massive marketplace, and a communication hub that completely rewired how we live and work. Right around the same time, a totally new way of building software started to bubble up. It's the open source model, and the perfect example is the Linux operating system. It allowed programmers from literally all over the globe to work together for free to build something amazing. This collaborative approach became a huge engine for innovation, and it still powers a massive chunk of the internet today. So that brings our story into the 21st century. This is where all those foundational ideas we've been talking about just explode into the technologies we use every day, moving computing off our desks and kind of into the air all around us. We're now living deep in the era of mobile and cloud computing. I mean, the phone in your pocket is way more powerful than the supercomputers that took up entire rooms just a generation ago. And the cloud gives us near instant access to almost unimaginable amounts of data and processing power wherever we are. All of that power is what's fueling the explosion we're seeing right now in artificial intelligence, a field that's been around for decades but is only now starting to show us what it can really do. Now, remember that first timeline we looked at with thousands of years between breakthroughs? Just compare it to this one. Now we're seeing world-changing inventions pop up every few years. Those key moments, the transistor, the microprocessor, the internet, they didn't just add to progress, they multiplied it. They kicked off this exponential curve of innovation that we're still riding today. So, we've gone all the way from the abacus to AI. We've seen an acceleration so fast that a person could be born when the first electronic computer was switched on and live to see it evolve into a global intelligent network. It's pretty mind-blowing. And it brings us to one final big question. Given this incredible momentum, what comes next? What will the next generation build with these unbelievably powerful tools?